Hello everyone, this is Dr. SUMIT CHAUHAN. Today in this video we'll talk about network layer and specifically about the logical addressing, and we do call it IP addressing. Learning objectives are: we'll discuss about internet address, classful addressing, subnetting, supernetting, classless addressing, dynamic address configuration, and network address translation, NAT. IP addressing, we have two versions. One is IPv4, the another one is IPv6. In version 4, an IP address is a 32-bit address. It's a logical address, and the IP addresses are unique and universal. 32 bits have been divided into 4 octants of 88888 bits, and the maximum value of an octant is 255. So the minimum value is 0 and the maximum value of an octant is 255. Now change the following address from binary notation to dotted decimal notations. Since it's IPv4, we have an octant of 8888 bits. So the complete address is of 32 bit. So we replace each group of 8 bits with its equivalent decimal number and add dots for separation. So this is the answer. And now this example is the reverse of the previous example. It says that change the following IP addresses from dotted decimal notation to binary notation. In classful addressing, the address space is divided into 5 different classes. We have A, B, C, D, and E. We have a class A where the first bit is 0. In class B, the first two bits are 1 and 0. Class C, we have 110. In class D, we have 1110. And class E, we have 4 times 1. Now this is a flow chart of the to identify whether a particular address is from which class. So if the first bit is 0, it means it's a class A, but if the first bit is 1 and the second bit is 0, then it's class B. But if the first bit is 1, the second bit is 1, the third bit is 0, then class C. And but if first bit is 1, second bit is 1, third bit is 1, fourth bit is 0, then it's class D. And if fourth bit even is not 0, then ultimately it's class E. Now here's some exercise to identify the classes of each address. The first one, since the first bit is 0, the class is A. And the last one, B, when all ones, this is a class E. Find the class of each address. 227, it makes class D. Then 252, class E. 134, class B. Now in different classes, we have different network address bits and host address bits. In class A, we have only one octant that is associated to network bits. The rest of the 3 octants, 24 bits, are basically host bits. In class B, we have 16, 16. 16 for network address and 16 for host address. In class C, we have 24 for network address and 8 for host bits. Class D and class E are actually for multicast address, and class E are basically used for this, are basically reserved for future use. Talking about the net ID, so it's a class A. Class A has first 8 bits as a network ID, and the rest of 24 are basically associated to network host address. So the first octant has a value 73, then it will remain 73, and the host bits will be represented as 000. That would be it's a network ID. Millions of class A addresses are wasted. Now block B has basically two octants as network ID. So the value that is there in the two octants are basically written as same, and the value in the rest two blocks which belongs to host ID will be represented as 00. Now the number of addresses in class C is smaller than the needs of the most organization. Since in C class we have 24 bits for the network address and we only have 8 bits for the host addresses, and that's why the addresses in class C, the number of addresses in class C is smaller. Same way, it's basically 192 is a class C address. So we have a first 3 octant as network ID, and the fourth octant will act as the host ID. In classful addressing, the network address is the one that is assigned to the organization. We take an example. If the address 23.56.7.91, find the network address, then 23.0.0.0 is the network address. Since it's a class and the first 8 bits are used for network address. Now here we have 132.6 as a .0.0 as network address, since it's a B class address, and in B class address we have 16 bits as net ID. Network address has been given and it has only value in the first octant, and the value is 17 only, and up to 0 to 127 we have class A. So it's a class A address. Network address is different from a network ID. A network address has both net ID and host ID, with zeros for the host ID. IP addresses are designed with two levels of hierarchy. Addresses in a network with and without subnetting. So if we have a net ID, say 141 to 14, and host ID that is 192 to 2, that is without subnetting, and then we have with subnetting. Conclusion is the IP address is 32 bits. There are 5 IP addresses classes A, B, C, differ in number of hosts. Class D for multicasting, class E is reserved. Subnetting divides one large network into several smaller ones. Thanks for watching.